Hey everyone, it's James here from STEM Pioneer and Understanding Data, and this is the first in a series of about 40 modules that we'll be doing, and this is a Python for SEO course, so we'll be mainly working up from all of the easy content to more difficult content. I just wanted to say, as this is the first module, I'll give a breakdown of how course content will be rolled out. So modules will be progressively rolled out on GitHub and YouTube, and you can find that at James A. Phoenix at Python for SEO. And I'll also add in the YouTube links further up in the GitHub repo when I've got those ready. In terms of what you need to do, if you need to be familiar with Python and have prerequisites and for loops, if statements, etc. But the easiest thing to do is essentially go to your command line. This course is going to be quite fast paced, by the way. So we're going to go to the command line, do git clone this specific repository, which is GitHub, https github.com, James A. Phoenix at Python for SEO.git. You'll get access to all of the Jupyter notebooks with the solution code in one of them. And then one of them that we'll be going through in each lesson is actually just typing out the commands and going through the starter code and explaining everything. So yeah, looking forward to going on this journey with you, and let's get to it. So we're going to be working from the starter code Jupyter Notebook. So if you want to open that, if you're not familiar with Jupyter Notebook, go and watch a course. But generally how you access notebook files is after you've installed Anaconda, then use Jupyter Notebook inside of your terminal and you'll be able to access notebooks. So today what we're going to be looking at is keyword deduplication and comparing keyword lists. So we're looking to learn how we can deduplicate keywords, how we can compare two lists in Python, how we can deduplicate keywords even better using a Python package called Fuzzy Wuzzy, which allows us to do partial exact match string matching deduplication. We're also going to be pulling some data from an hrefs, a CSV file, and really getting stuck into using Python Pandas rather than Excel. This will allow you to do all of your data munging and data manipulation inside of Pandas, and therefore you can completely automate that process, put it into a Python script and push it directly to CSV or G Sheets. We're also going to be looking at how you can customize Pandas and use group by methods. We'll all be exploring how you can also improve your deduplication efforts when it comes to keywords by using, for example, .lower and also NLP, lemmatisation and stemming. So yeah, let's get to it. So the first thing that we're going to do is import pandas as PD. Now let's briefly just go through deduplication of sets, keywords with set operations. So the first thing that I'm going to get is I'm going to get two Python lists, and you can either type these out, but I've already got them pre-canned. So we've got some keywords that we've got from Google Search Console, and we have some keywords that we have from paid search. Now, what I'm really interested in, we can print these just by doing print. And just to let you know, Python stores keywords strings inside of a list, and it's just a square brackets. You've got like that's how you make lists. Anyways, so we have two keyword lists, but what we'd really like to be able to do is, how do we deduplicate them? We can deduplicate keywords by using the set operation, and this will remove exact duplicates. So you can see here we had SEO. So here we don't have any, but let's add one in, for example, just to show you. So if you have machine learning twice, you can see now we only have one machine learning because we've essentially transformed this Python list into a set. And this is great for catching exact duplicates. The problem with this is it's in a set format. We can rewrap it back into a list. So for example, we could do this. And now we have a deduplicated list of Google Search Console keywords, which you can see here. So we no longer have, hold on, machine learning. Interesting. Yeah, so I didn't actually create those. Hold on. Machine learning, here you go. There we go. So you can see here, we've only got one machine learning. Cool. All right, so that's nice for getting rid of exact duplicates using a set operation and then repackaging it back up into a list. But we can also compare both of the lists by also making them into sets. Okay, so an example of that would be something like okay. So just to go through that again, we can have a list which has duplicates. So you can see we have machine learning here and machine learning here. What we can do is we can do the following. So we can get Google Search Console keywords. You see we've got duplicates here, machine learning. We can wrap this in a set, and we've only got now one version of machine learning. We can repackage it into a list, and then we can reassign it. And now if we print Google Search Console keywords, you'll see we only have our one machine learning, which is great. So let's also move on, and now we're going to talk about the benefits of using deduplication using the Fuzzy Wuzzy package, because sometimes, for example, you can see we might have something like this: machine learning, let's say maybe like data science service, data science services. So these are all partial duplicates, right? These data science services, data science. So we'd like to be able to deduplicate our list to really get a refined idea of what kind of keywords we're looking at. So one thing that we can do is we can use in this section, what we're going to be doing is comparing two keyword lists using set operations. So let's get to it. So we're going to create our list that we created earlier, for example, like this. Now we're going to convert both of these lists and use the dots intersection functionality on sets. And this will allow us to figure out which keywords appear in both lists. So this could be quite interesting if you pull some data from Google Search Console, you pull some data from paid search, and you would like to find the intersection, which keywords you're actually appearing for in both platforms. So let's get to it. So what we're going to do is we're going to wrap two sets, and then we're going to put them both into sets like this. And then we're going to do dot intersection like this. Now you can see here, so we have data science consultants appears in both lists, data science marketing, digital marketing even, search engine optimization, SEO. Okay, that's great. So we could, for example, say in both lists. And at the moment, this is a set, but you could equally transform this to a list, for example, and do what you want with it. So this shows you how you could find keywords that appear in two different keyword lists and figuring out the intersection between that using set operations. But now let's figure out, okay, I've got some keywords in Google Search Console that might not be in paid search, and I have some keywords in paid search that might not be in Google Search Console. So what we're going to do is we're going to find, to start with, all of the keywords within Google Search Console, that list, that aren't within the paid search keywords list. And we will do this operation. So this shows us all the keywords within Google Search Console that are not in paid search. So it'll make more sense when we actually print it. So you can see here, for example, data science is not in the paid search keywords list. We also don't have ML consulting. We don't have social media. So this is a great way for you to be able to find, okay, I've got 100 or 1,000 or 10,000 keywords in paid search, and I've got the same in Google Search Console, and to be easily able to just go, bam, right, what are the difference? And if we completely reverse this operation, we'll get the exact opposite result. So we're basically saying, what are all the keywords in paid search which aren't actually in Google Search Console? Okay, cool. So this means that all of the keywords here that we have in paid search are in our Google Search Console. And we can also extract all of the unique keywords across both lists using set union. So I'm just going to get the code for that now. And essentially how this works is we convert both the Python lists into sets, like this. And hold on. And then what we're then going to do is say all of the uniques in Google Search Console keywords and all of the uniques in paid search keywords, I want to see the union of those. I want to see everything. And this means that we can basically merge both groups but remove exact duplicates. Okay, cool. So now we're going to look at some Boolean logic. So we can do something using something called isSubset. So the usefulness for this would be to say, are all of the Google Search Console keywords in the paid search keywords list? Are all of the paid search keywords in the Google Search Console list? So we convert both to sets. And then basically what we're saying is are all of these Google Search Console keywords, are they a subset of the paid search keyword set? So if this was true, then it means all the Google Search Console keywords are inside that paid search set. And similarly, if all of the paid search keywords were a subset of this set, then all of those paid search keywords were inside a Google Search Console. So this can give us an immediate reading and a pulse to see, have we got all these keywords in or are there some missing? So let's run those commands and then let's print the results. So from this, we can see that all of the Google Search Console keywords are not in paid search, which might mean we have some keywords that we could potentially add. And then all of the paid search keywords are they in the Google Search Console list? They are. So that means that we've got all of the keywords in our paid search account into Google Search Console, but there might be some keywords in Google Search Console that we might actually want to add to our paid search account. Cool. All right, so we've learned about sets and how we can use those to deduplicate Python lists, and also how we can compare two lists by converting them to sets and finding the differences between them, finding all of the uniques, and also just doing some simple Boolean testing to see, are all of these items inside of this set? Are all of these items inside of that set? Cool, so let's move on. So we're going to be talking about a Python package called Fuzzy Wuzzy, which is absolutely great for paid search and Google Search Console's keywords, specifically for deduplication. There's loads of situations where you'll have keywords like digital marketing service, digital marketing services, digital marketing service, and all of these things kind of mean the same thing. And Ahrefs does a really good job at categorizing them into parent topics. But we'd also like to be able to do that ourselves. And there's a Python package that we're going to install called Fuzzy Wuzzy. And this basically works on using Liebenstein distance to figure out how likely two strings are to be similar, given how many characters you either have to add or delete to get from string A to get to string B. Okay, so there's an easy way that you can install additional Python packages directly in Jupyter Terminal. So we're going to do that. So you can use pip install Fuzzy Wuzzy like this. So now we're actually installing this. And then what I'm going to do is I'm going to just restart the kernel. So you go to the top there. So I'll do that again. So kernel, clear and restart output. We're going to go back up and we're going to re-import pandas. Just re-execute that line there. Okay, great. Now we're going to see how we could use Fuzzy Wuzzy in action. So the first thing we've got to do is we've got to do our imports from Fuzzy Wuzzy. And you can type this if you'd like. So just pause the video and type this out. From Fuzzy Wuzzy, import fuzz. From Fuzzy Wuzzy, import process. We can actually reduce this to one line. And that's just a warning about using Python leaving sign if we want more performance. So no problems there. Okay, cool. Now I'm going to use a keyword list example that we had some duplicates in. So you can see we have some dupes in here, but we also have some partial exact match dupes. SEO copywriting, social media marketing, social media. Pretty hard to get if we're just using sets. But actually, let's see this in action. So what we're going to do is we're going to do something called using the process method, process function. And we're going to do this. Process.dedupe, and then you're going to pass in your Python list, and you're going to set a threshold. Now I'm going to explain the threshold because I think it's really important that you get a good understanding of this. If you were to set the threshold at 0, the intuition behind that is that you would have lots of changes to the strings, and the strings would be very different from each other. If you had a very high threshold, it would mean you would have to make only a few changes to the strings to get from string A to string B. So if the threshold is very low, you're always going to deduplicate everything. But the problem is that you might be over deduplicating and comparing, for example, digital marketing versus social media marketing. Maybe that's not necessarily the same thing. So we're going to set a threshold of 70 leaving sign distance to start with. So you can see here we've got digital marketing services, SEO copywriting, and social media marketing. So stuff that was removed was social media, copywriting, digital marketing. Perfect. All right. It's also worth knowing that you can see here it's taking the longer keyword, right? So you can see copywriting was removed and the master was assigned as SEO copywriting. Similarly, we had digital marketing being replaced by digital marketing services. So then we could say dedupe list. Like this. Let's remove the print statement. Now we can print that out again. So now we have our deduplicated list. And you can see here it's actually some dict keys. So let's just wrap this around a list to make it, with a list command, to actually make it back into a list, like so. Okay, great. It's also important to note that when we pass this threshold, we can go between 0 to 100, and you'll really want to try and tune that parameter. There's a balance to this. If you set the parameter too low, then what's going to happen is you're going to get bad duplicates. If you set it too high, then maybe you're going to miss doing a deduplication that would actually have made sense to do. So we could run some pseudocode to see, okay, if I set the threshold at different levels, what kind of different results do I get back? So let's do that. So we're going to create a dictionary called threshold dictionary. And then what I'm going to do is I'm going to run this for I in range, and let's just print I so we can see what's going on here. So I'm going to say start at 10 and go up to 100 and go in excluding 100, but go up to in increments of 10. So this is going to allow me to easily change and tune that parameter. So essentially what we're going to do is we're going to rerun this, and we're going to use the exact same keyword list, and then we're going to change the threshold using the value of I that I just showed you when we printed it out. Then we're going to save each of those threshold values as a new key and make it into a list. So let's run that. Cool. So you can see that we've actually had different current values of the threshold all the way from 10 to 90. And you could change this and do increments of 5 or do increments of 2, however you'd like to do that. So let's have a look. So you can see here when we set 10, we only found one result within that range. However, if we look at like 70, that looks pretty good. You can see 90 we've got 3, 80 we have digital marketing services and SEO copywriting. I'd say social media marketing is kind of separate to digital marketing services, which I'd say why this is quite good. But you can see as we get lower, there's potentially less duplicates. So that's how we can use the Fuzzy Wuzzy Python package to quickly deduplicate a list using partial exact match string matching. So in this next section, what we're going to be looking at is taking some data from a keyword report from Ahrefs. I've got some local CSV files saved already for you, which you can find in the keywords data section. And we've downloaded some keywords called digital marketing keyword ideas.csv. So we're going to take that data in via Pandas, read the CSV data in. We're then going to perform some operations on that. We'll do some querying, look at some different columns, and we'll just get you comfortable utilizing Pandas so that you can utilize it to replace your Excel processes, which means that you can start scripting more and just automating more of the keyword sorting, searching, etc. So just before we go on, the syntax that we use for importing a CSV is pd.readcsv and then the file path.csv. And the important notes are that I found that when you download keyword data from Ahrefs Keyword Explorer, it's tab separated rather than comma separated. So we have to pass in this extra delimiter that you can see here. The encoding will depend upon how you download it. So I've included 2 example codes, either UTF-16 or UTF-8, depending upon which one you choose. So, all right, so let's actually go and download this. So we're going to do pd.readcsv, and then we're going to do data/digital marketing keyword ideas.csv, and we're going to save this to df. Now you'll see this fails, so let's put the actual right encoding in. And interestingly, it still fails. So let's actually put the right delimiter in. And I know that after a lot of playing around with Ahrefs, it is tab delimiter that they use to store their CSV data in. So if we do df, we can see we have all this beautiful data. So we've got 1,000 rows, 12 columns. So now what we're going to do is we're going to work through and just do some simple operations in Pandas to get acclimatized to this. It's like Excel, but it's for Python wizards, so hopefully you enjoy it. So df info allows us to see all of the different data types. So we can see we've got objects, which are strings, we have floats, we have some integers as well. And it also shows us like what rows we have. So we have 1,000 of these, we've got no missing values. Here we've got 599 and we have some missing values. So it gives you an idea as to like how many missing values you have in each column and the different data types you're working with. And what's really cool about this is essentially we can do a range of different operations. So, but what I'm going to do first is also go through how we can select multiple columns. So I showed you how to do single columns with df.keyword or keyword, and that's a single square brackets. But now let's see how we could query multiple columns. So we could do keyword. So the query multiple columns, you do a double square bracket. And then we're going to query keyword. We're going to, actually, let's do CPC and clicks. And then if we were to look at the type of this object, it is a data frame because it is more than one column. All right. So that's how you can query specifically either one column or 2 columns. So now that we know how to like select columns, let's move on to how we can index our rows. So there's 2 ways we can do this. We can use .lock, which refers to the column names and the index names. And it's probably easier if you see this in practice. So I'll just briefly go over ilock as well. Ilock is the actual position, remembering that index always starts at 0. Kind of like your Python lists. And this is going to look at the position either on the columns or on the rows. So let's just keep it simple to start with and just actually put everything in by doing a square brackets comma, colon, comma, colon. This will do everything for both iLock and lock. Now let's say we wanted to get, so we know from looking at something like df shape, you can see here we have 1,000 rows and 12 columns. So always remember rows and then columns, rows and then columns. So let's look at this now. So we know that lock works on names. So let's pass in just one to start with, and let's look at the keyword column. Okay, that's cool. But how do we do many? We can literally wrap it inside of a list. So if we just look at our df, and we can use df.head6 to look at the first 6 rows. We can look at df.tail to look at the last 6 rows. So this is great. So now let's look at, okay, what I want to do is I want to see all of the volume as well. And maybe I want one final column. So I want last update. Cool. Now let's say I wanted to get rows 0 to 100. 0 to 100. And you see here we have 100 rows selected, 101, because that's inclusive, because remember indexes start at a position of 0. So if we wanted to get the first 100, we would do 0 to 99. Then we get 100 rows. Cool. We could also do increments, so we could increment by 5. You can see here we're now incrementing by 5 rows at a time. Yeah, so that is generally the .lock method. Now let's have, it's also worth knowing that you can chain methods together, like this. We just learned the .head, which looks at the first 6 rows. Okay, now let's look at the .ilock method. So let's first put everything in with a square brackets, colon, comma, colon. Now what we're going to do is we're going to look for the first 10 rows. Notice how this isn't including 11 because it's only counting the actual position. Position starting at 0 and ending at 9 for the first 10 rows. Now let's say we want to get the first 3 columns. We could do 0 to 3. So we get in the hashtag, the keyword, and the country. Now let's say we want to get columns 3 to 5, 3 to 6. Cool. So we can also query columns by their position. You can also pass in a list of positions to get different columns at different positions. Similarly, we can also do the increments. So that's increments of 5s, increments of 1s, increments of 2s, increments of 1s. Cool. And if we wanted to get all rows, we can just leave it like this. So those are some easy ways that you can filter, and if you want to save this specific view, you can just do like a new data frame, right? Assign it, reassignment, and then when we query new data frame, we have access to that specifically sliced data frame. Okay, now we're going to move on to sorting data frames by column values. So some things you might do in Excel is sorting all of your column values by a row. By a column, and so we're going to do that in Pandas. So the way that we can do that is by doing sort values, and then we pass a column name. So let's have a look at all the columns by doing df.columns. So let's sort everything. I'm going to say by volume. And notice here how the order is setting at ascending. So we've got everything starting at 0 and ending at nan. Maybe I want to do it in descending order. So I go ascending is equal to false. So now I can see all of the keywords that have the highest search volume on a monthly basis. Now, it's really important to note that if I do df here, notice how the column actually hasn't changed. For example, if I was to do ascending equals true, see we've got 0. But if I redo the df, we have all the search volume keywords at the start. So if you want to save that view, you can just do in place is equal to true. Now when we look at the data frame, we can see that everything goes from 0 to the highest and then nan's ending at the end. So let's change this back to false just to demonstrate the point again. So you can now see that if we query the data frame, we can now filter and get all of the keywords that have the highest search volume. Now, if there were two keywords that had this highest search volume, we could actually filter them by multiple columns. And we do that by passing a list. So we could say, first filter by volume, and then filter by difficulty, like this. So that's how you can filter by multiple columns. We could also filter by other columns. So you could do, for example, CPS. So you can briefly just do that. Highest CPS, cool. Yeah, so hopefully that gives you an overview as to how you can sort values and sort your data frame by 1 or 2 columns. And you can do as many as you want in that list. Okay, great. So let's sort the values by CPC. Perfect. And then we're going to in place true to that. Now, what's really cool is Ahrefs gives us a parent keyword column. So what we're going to do is we're going to remove any keywords that don't have a value for this. And we can do this with .drop NA and then subset on the column name. So this allows us to drop any of those np.nans, which are otherwise known as not a number values from the data frame. So let's do that now. You can see here we've got these nan values, especially in the parent keyword. So we're going to do drop NA, subset. We can do this as a list. Go change the documentation. Sweet. All right. And then we're going to do in place equal to true. Now, if we have a look at this data frame now, you can see we have reduced from 1,000 rows to 602. We've still got the same number of columns, but we no longer have any NAs in the parent keyword column, which is quite nice. Now, we're going to look at how we can group single keywords by their parent keyword. And we'll do this by using the .groupby and then passing in a column name. And this allows us to group multiple keywords that have the same parent keyword and to get aggregation metrics on difficulty, volume, CPC, clicks, CPS, and return rate. So let's do that now. So let's do group by df.groupby and then do parent keyword. Now you get this group, and the thing that we're going to do when we're looking at this group by object is we're going to do several things. We're going to save it first to a new variable. So we'll call that group parent keywords. So now we can refer to this like that. Now, in order for us to actually see the data frame and to see this specific data frame, remember it's aggregated. So we're going to need to do some form of aggregation metric. So for example, we could do the .mean. And you can see here now we've got the parent keyword as the index, or we could do .count, or we could do .sum. That's summing all the volume for parent keyword. And you can do other things. So you can do, for example, sort values. So we can sort that by CPC. We could do ascending equals false. Now we can see that the most important parent keywords are digital marketing agency, social media marketing agency. Okay, well that's good. And the least ones are here. We could also say I just want to see the top 20 rows, top 20 parent keywords, for example. We could say I want to see all of them. Nice. Okay, so you can see how utilizing different methods like .sort values and also by doing some row indexing would allow us to mix this up. So that's all fine and great, and you can do a range of other ones such as median as well. But for our analysis, we're actually going to make a custom aggregation function, and this allows us to perform mean, count, sum, median on specific columns and gives us a bit more functionality. So I've already got one cooked up that I'm going to actually just share, and I'll go through this. So we're taking this variable that we previously defined as a group by object. We're calling the dot aggregation function, and then what you do is you pass in every column name and what type of aggregation you'd like to do. So obviously we'd like to know how many keywords were inside of that parent keyword group. We'd like to know the mean difficulty, the sum volume. We'd like to know the mean CPC and the mean CPS, and we'd like to know the mean return rate. And we're gonna do an in place equals true on that and reassign it. So now let's have a look at this. All right, cool. So we now have our custom aggregation. So we could, for example, look and see what parent keywords have the highest amount of keywords in them by doing something like sort by keyword. All right, so digital marketing agency, digital coast. Let's have a look at the 30 rows. Nice. All right, cool. So you can see how we can immediately get access to some grouped aggregated data. We could even assign this to like a temp diff, like a new variable like temp df. So this is a we do section, so I highly encourage you to follow along, especially if you haven't been coding already. So we're going to take this group by parent keywords, and we're going to sort values by difficulty, and then do ascending equals false, in place equals true. And that would sort all of the values by difficulty, which you can see. There you go. So those are the most difficult things to rank for. Equally so, we could do something like this. Let's just copy this line actually, probably easier. And let's do volume instead. Remember, we can still sort by multiple columns if we want by doing something like this. So this would sort by volume first, and then we could sort by CPC after that. And we've used the in place true parameter. That means that all of our changes would always be applied to this data frame. You've learned about how to sort columns, how to use simple group by objects on a single column name. And this means that you can really get some aggregated metrics around those topic keywords, specifically in Ahrefs Keyword Explorer. So we're going to be moving on to how we can remove duplicates within our data frame. So this is the ungrouped data frame, just the df. And what we'd like to do is maybe deduplicate it. We could do that with something called drop duplicates. And let's do that within our keyword column. So we're going to do subset is equal to keyword. Okay, great. So there are 602 exact keywords that are duplicates. So let's do in place equal true. Now when we look at this, we've got 602, which is nice. So we've deduplicated it. You could also have multiple ones, so you could deduplicate by keyword and if the clicks were different, for example. But just for the sake of this simplicity of this tutorial, we're just going to deduplicate if the keyword is different. You can see here, this is a syntax, but as I showed earlier in the start of this tutorial, we were looking at keywords and how we could deduplicate those with set operations. And this is great in a simplistic sense because we could practice it immediately. But let's say you wanted to get those lists from Pandas data frames and also your Google Search Console data and even CSV data. Let's go and get some lists from columns so that we could actually start performing Fuzzy Wuzzy operations and set operations for further deduplication. Cool. So let's, for example, select the keyword column. There is an operation called toList that allows you to get all of the keywords, which is pretty nice. So we can get those as a list of keywords. And then we'll just call this parent keyword list. Yeah, okay. All right. So then we could, for example, do something like process dedupe using the Fuzzy Wuzzy. We could pass in this keywords explorer list, and then we could set a threshold of 80. And now we're deduplicating the list based upon partial exact string matching rather than purely exact duplicates. Pretty nice. So let's see, and then I'm going to let this run, but I'm going to I'm going to see deduplicated keywords, and we're going to actually stop that, and then I'll just make sure that that is a list, and we can check the length of our list by doing len. We've got 602 like you saw previously, so let's just leave that running, and whilst this command is running, I'm going to put a print in deduplicated keywords. Just hit shift enter again. Alright, so we'll leave that to run and to crunch and do some deduplication. Whilst that's going, let's look at how we can filter our data frame, and this is called data frame filtering or data frame subsetting. And the easiest way that we could do this would be something by like an equals operator. So for example, if the keyword is equal to a specific name like HubSpot, this would return a series of booleans for every single row. And then what we're going to do is either do something like this where we create a mask, or alternatively we would do something like this where we have the original data frame and we would put our condition inside of that. If you're using the mask, you would do something like this, df mask. Okay, cool. So we've got some dedupes, which is nice. So let's have a look at what Fuzzy Wuzzy thought was actually how many keywords we really had. Cool, so we've already gone from 622 to 255. It can take a couple of minutes, half a minute, especially when you start getting into the tens of thousands of keywords. So definitely be careful with that and be patient. So now we can run these commands. You can't run commands if something else is running, but great. So let's see what this mask looks like, for example. So you can see we've got a series of booleans on rows. Now let's try with the first method. So we do df mask. All right, cool. So we did find one keyword, which is quite nice. And let's just, for the sake of this tutorial, let's also try the other method. So let's put the chain command in here. Hold on. This looks like the right command. Cool. So you can see this one here, if I on command, we're getting the same type of response. So you can use either of these two approaches. Alternatively, we might want to use like a greater than or equal to, greater than, less than, or even greater than or equal to or less than or equal to operator. So let's, for example, do a code long now. Let's see, and let's filter our data by any columns, any keywords that have a specific search volume greater than 50. So obviously we're going to do this together. So we'll do df volume greater than 50, and you can see we get the same sort of boolean for each row. Okay, so we can wrap that like this, and if we wanted to assign this, we could do it like that, and then our df would then always be like this. Cool. This is the one way, and the other way that I showed you previously is just assigning this value here to be a mask. Mask 2, and then essentially it would be doing something like this. Cool. So now we only have keywords that have a higher volume than 50. We can also do several columns though. So let's do one of those, and what I'm going to recommend is we do something like this. As we've already got one command on, let's do something like this. So we can do the dataframe is volume is greater than 50, and CPC is greater than 2. All right. So now we are at 09 rows. Originally before that we were at 432. So after applying this additional Boolean logic, we can now get an even more refined data. And we could save this as a temp data frame, for example, or any variable name we like, and we can reference that. Cool. You can chain this as many times as you want, and the way that you structure these is that the condition goes inside of an open and closed parenthesis. If you're doing it chain conditions, and you want to use the the conditions to be and, use the ampersand symbol. However, if you wanted it to be, it would be essentially like this, similar to these. However, let's say you wanted to do ORs, we're also going to cover that as well. So for example, this is how it could be written. Cool. Let's also look at how we can do OR operators, which is with the piper operator. So it could be written like this. So notice how everything stayed exactly the same, except we've just swapped out the ampersand symbol for a pipe operator. So either this condition is true or this condition is true. Nice. You can resave that. You can see now we've got more columns because we're allowing it to be this has to be true or this has to be true. Alright, in the next section of this notebook, what we're going to be going through is grouping deduplicated keywords with Fuzzy Wuzzy. Now obviously Fuzzy Wuzzy comes with process.dedupe, which allows us to deduplicate a Python list into a smaller list that we saw earlier. We applied this on simple Python lists and also converted a Python data frame column of keywords into a list and did it on that. But we could also do something similar where we have 10,000 keywords or 100,000 keywords, and we want to not only deduplicate the keywords, but we also want to group them based upon how they were deduplicated. So I'm not going to necessarily explain the logic inside of this, but what I am going to do is give you guys a custom function that's written completely from scratch, just using a simple algorithm that I made. And essentially what we're going to be able to do is pass in a data frame, pass in a column that we want to deduplicate, pass in a limit that is the size of how big that group can ever be, and pass in a leaving sign distance threshold. We're then going to drop the duplicates on that specific column. We're then going to process all of the data and return some keyword groups. So I'm now going to show you how you could run this kind of function. So we previously had a data frame called df. So you can see we're passing that in, and the one that we want to actually do some fuzzy wuzzy string matching against is a keyword list. So we can do column name is equal to keyword, and the limit on the size of the group that we think it should be is 6, and we're going to use a leaving sign distance of threshold of 70, and then we're going to reassign this to group words. Now I'm going to leave this to run because it takes like maybe half a minute or a couple of minutes depending upon the size, and then we're going to process some output. So here what I'm doing is I'm basically just creating this new completely empty data frame called pd.dataframe, and then as the result that we get back from here is a dictionary, and we can see that we return that to this variable. Let's actually have a look at this. So we got all these, so for example, digital marketing industry. You can see we got website marketing, digital marketing UK, digital marketing. Let's look at another one. So we got HubSpot, we got HubSpot. So it's not necessarily perfect, but it's going to give you a good sort of grasp on potentially the types of groups of keywords that you might see. You're going to get whats that are going to be grouped together, defines that will be grouped together. It's not exactly perfect, but I find this to be great, especially if you're not using anything where, like for example, Ahrefs gives you a parent keyword topic. But if you didn't have something like that, this is an easy way that you can just pass a Python list and a data frame into like a data frame with a specific column that you want to find some keyword groups for, and it will do quite a good job. So now what we can do is we've got an empty data frame here, and we're going to load in from the dictionary. This is the dictionary. We're going to orient it by an axis of index. So now we're just going to look at the top 20 rows across all columns. And you can see here, these are the specific parents. And then these are all of the keys with the Liebenstein distance score that we obtained from matching that. So yeah, so that's exactly how you can form some easy groups using Fuzzy Wuzzy and a custom function I made. Hey, what's up? So what we're going to be looking at here is 2 additional ways that we can utilize to improve our deduplication efforts. So the first one that's very, very simple is the using .lower. And I'll give you an example of why you might want to use .lower. And we can just see that. So for example, we have 3 keywords or phrases that are exactly the same except capitalization. What we can do is we can just use the .lower, which is a string method inside of a list comprehension. So we loop over every item in this, and just to show you what happens if we do for word, you can still see these are the same. But as soon as we use .lower, we can already clean up our phrases, and this is great for when we want to convert it to a set. And then you can see here we've immediately deduplicated our keywords. So that's great if you have capitalization errors. That works like a treat. Yep, cool. So now we're going to move on to something slightly more complex, which is called stemming and lemmatisation. Stemming and lemmatisation allows us to make sure that words are returned to the root of them instead of using the prefixes and suffixes of words. Basically, we can remove inflectional endings to only return the base of a dictionary form of word, which is the lemma. Luckily, I've already got some stemming and lemmatisation functions that we can use, and we'll be using that using a .apply method with our Pandas data frame. But before we actually get onto that, we're going to need to do something quite quickly. So what we're going to have to do is we're going to have to do pip install NLTK. Now, if you've already got requirement satisfied, that's great. That means you've already installed NLTK. However, if you haven't, you're going to need to restart, clear the output of the kernel, reload the Pandas data frame module, reload Fuzzy Wuzzy. Then we can scroll all the way back down to get back to NLTK. You can now activate these libraries and import them. And I must say these are quite heavy libraries, so it might take a bit of time to load. So I'm just going to move on. So essentially we have 2 stemmers here, a Porter and a Lancaster stemmer, and these will allow us to stem phrases and keywords. We have a range of functions here. This will stem an entire sentence. This will rejoin all of the words together. And this will prepare a list of stemmed words. Now, what I'm going to show you is how the apply method works, because I think it's really important that you get a grip with this. So for example, if we have a we're going to re-import the data frame, so pd.read csv data, and then let's see, yeah, that's the one I want. Delimiter equals tab separated, encoding, nice. Obviously, if you didn't restart the kernel, you don't have to do that. So let's get a list of these. So we can get a list. Now let's see what happens when we do an apply method. An apply method kind of works like it'll either do the specific rows or it'll do the specific columns. So let's just do a lambda function, and I'll explain what a lambda is in a second. So every row we're assigning an iterable of x, and we're essentially returning x. So for example, if we were to square this, because it's a string, we get 2 of the same thing. So let's do, for example, x plus this plus x. So you can see here, x, which is whatever is inside of the row, we're going to do one of those plus a space plus another one. But that's not necessarily a useful lambda function, but it shows us how this essentially operates. So you can also apply a function inside of a lambda method. So for example, we can use test instead. that takes in every string of the row. We'll print X here. And then essentially it's just going to return it. Get rid of the lambda. And then no parenthesis, like so. So first we printed it, which actually happened inside of our test function. But you can also see that we've returned it, so it's come back with a length of 1,000. So let's remove the print statement. Okay, cool. So what we're going to do is we're going to apply some stemming to our keywords. And I've already got some code that I'm just going to showcase. So what we can do is we can use the stem sentence method, and we can use that on our keyword column. And then we can assign it to a new column called df stems keyword. Let's see. Okay, so we need to install import NETK. So we need to download the punct. So let's do that. Import NLTK, and then now that's essentially just downloading some punctuality and some of the packages. So now if we run this and let's look at our stemmed keyword, I'm actually going to use this quotation as we have a space. Alright, so you can see we've got content mean, email market, digital service, all digital market service lists. So you can see some of the words are essentially stemmed and reduced to their root. Okay, cool. We could then actually take this, and I'll show you how the extra column looks as well. So let's just do df head equal to 6. You can see here we've now got a new column with our stemmed lemmatized keywords, which was from here, by using the apply method. Okay, cool. So what we could do is we're going to deduplicate our, we're going to take a, I'm just going to say here about here, df head equal to 3. So now let's get all of those stemmed keywords and deduplicate them as a list. And then what we're going to do is we are going to then, so we then have these stemmed keywords from our final column, which are deduplicated by using setList. Now we're going to further deduplicate them using Fuzzy Wuzzy. And once that list is done, what we're going to basically do is use something called the isIn, and that will allow us to look and see, do these stemmed unique keywords appear in this Python list? So we can do something like this. Does the stemmed keyword exist within this list that we're now creating? So if we copy the code for that. And then instead of this, we would like to use stemmed unique keywords, and we can assign this to like a mask, for example, unique stemmed keywords mask. And then we could use this mask inside our data frame. That's one way we could do the filtering. The second way would just be to do something like this. Now, whilst this is running, essentially what this gives us is we look at the stemmed keyword column, and then we have our uniques that we've deduplicated using list set of stem keywords. We've also then deduplicated them with Fuzzy Wuzzy, And then we're saying for every item, for every row in this stem keyword column, does it appear in this list of deduplicated stemmed unique keywords? So now, for example, we get about 311 rows back. And we could say cleaned df. Now you'll notice in this new df that we also have the index is slightly off. We go from 1 to 4 to 10 because we've lost some of our rows. So we can easily fix that by doing reset index is equal to true. And then let's do in place to make sure that that is hard fixed. Cool. And I'm just going to delete a couple of columns because maybe I don't want some of those columns. So to do that, we just do drop, and we do columns is equal to, and I don't, for example, need the hashtag, and in this analysis, I don't need the country. And then if we want to, we can either save that with clean.df and do reassignment. That's one way to do it. Or we can just use the in place is equal to true. Now we can save our data specifically to a CSV. So to do that, we just do to a CSV. Learning Python is awesome.csv. And let's save the index as well with this. But you don't always have to. So you can choose whether you want to save this index column or whether you don't want to. And you know, that can be quite useful when you're pushing to G sheets because maybe you don't want an extra column that's just a load of numbers. Alright, so congratulations on making it to the end of this first tutorial. We did cover quite a lot. We went through Python sets, how you could compare two keyword lists. We also touched on process.dg with Fuzzy Wuzzy. We've then gone straight into Pandas, reading some data from CSV, looking at how we can select columns, how we can filter columns, how we can even group the entire data frame based upon columns. And then we've finally got into some more advanced methods, so creating a dictionary with a keyword grouping list, like a list of keys and values with keyword groups. We've also done NLP, stemming and lemmatisation, and using a list comprehension as well to do the dot lower. So yeah, I hope that you find this tutorial useful, and we're going to be rolling out about another 39 of those. So yeah, keep tuned and keep building links.